page 260, number 1, part A. Which graph of those three could be f of x equals 2x squared? Which one? A. I like A. Okay? So, now, me being the ever learner type person, okay, why can't it be B?
Because the exponent is like an even number.
So the degree is even?
Yeah.
Okay, so an even degree means it's got to go in the same direction on both sides, right? Okay, so this one here has an even degree. So this part, or B, can't be. Okay, why don't I like C? Daniel, what's not negative? Which coefficient? The lead coefficient is positive in this particular one. So it's got to go up, right? I heard. Okay? All right? So, not there. With me? Okay. What? Okay. Part B. Which one do I like? I like C. Okay. Why don't I like A? It's going in the same direction, right? So what kind of a degree is A? It's an even degree, right? But my function has an odd degree. So I don't like that one because the degrees don't match up. Why don't I like B? B would have a positive lead coefficient, right? And my function's got a negative lead coefficient. Okay? So this one has an even degree. This one would have a lead coefficient that's positive. Okay? Now, which one do I like in C? B and C? Because there's really no difference between them. I think it was a misprint in the book. But yeah, so I like B and C in this one. Okay? The last class was in a debate. Well, C is wider than B. And I'm like, I said there's no scaling, so it may look that way, but it really isn't kind of a deal. So why don't I like A? It's got a negative what? Lead coefficient, so I don't like that one. Okay, with me? Fantastic. All right, so skipping ahead to 264 now. Okay. The only thing that I want to talk about on page 264 is actually in that little writing, that little section right there. And so I am actually going to use what I like to call a highlighter. And I am going to say that, recall that the definition of a relative maximum is the highest point in a particular section. Okay? So relative maximum in Marathon County would be Rib Mountain. Right? Okay? That's a relative maximum. In this area, in this section of Wisconsin, Rib Mountain is a relative maximum. Okay? Alright? An absolute maximum is the highest point over the entire graph. So if I take the world as a whole, the absolute maximum is K2 in Asia. It's the highest mountain, it's the highest point on Earth. Okay? Rib Mountain is a relative maximum. K2 is the absolute maximum. with me on that? Okay. Doesn't get any higher than K2. Okay. Minimums. Okay, we can do minimums also. A relative minimum is the lowest part in a particular section of breadth. Okay? An absolute minimum is the lowest point over the entire graph. Okay? My parents' house in Florida sits at 12 feet below sea level. Okay? Right? Which is a low point. Okay? But there's some trench in the Pacific Ocean. I don't remember what the name of the trench is in the Pacific Ocean that's like 25,000 feet below sea level. Okay? So absolute, relative, right? Good deal. Okay? With me? Now, extrema are all of the minimums and maximums put together. Okay? So it's all the mins and maxes. Okay? Yesterday, we called those points turns. Okay? Okay? A minimum or a maximum happens at a turn. Okay? So the extrema is all of them. We just lump them all together. Okay? What I would like you and your shoulder partner to do is looking at number 2, which I believe is page 265. Okay? So looking at page 265 now, you and your shoulder partner determine just the number of extrema on all of those graphs. Okay? Go for it. Alright, so in the first one, how many relative extrema are there? X to the 4th. Just one? Kind of somewhere right in there? Okay. On G sub 2 of X, how many relative extrema? 3 of them. 1, 2, and 3. Any of those absolutes? We'll look at the first one first. X to the 4th power. Is that an absolute or is that a relative? Got 1 vote for absolute. Got 1 vote for relative. Does the function ever go below that point? No. So that makes it an absolute because it never gets below that. So that's an absolute. Okay? This first one over here, is this an absolute? Actually, these 2 minimums, we'll deal with both of them at the same time. Are those 2 minimums absolutes? Yes, because the function never gets below them. What about this maximum in here? Is that a relative or an absolute maximum? Relative, because the function gets higher than it, so it's not an absolute. Okay? 5th degree. I'm going to start on the right side and I'm going to work my way back to the left. So here we've got 1, here we've got 2, here we've got 3, here we've got 4. So according to my records, we got 4 extrema in that one. Yes? Any absolutes? Because the maximums aren't because the right side goes shooting up. And the minimums aren't because the left side goes shooting down. So no absolutes there. Okay. Middle one. I got 1 right there, and I got 1 right there. That gives me 2 for that one. Yes? Either one of them absolutes? Nope. Same reasoning. Right side goes shooting up, left side goes shooting down. Okay? First first one. I don't see any. I don't see any. 0. So if I don't have any, that means I don't have any absolutes. I don't even have any relatives. Okay? All right? 6th degree. Again, I'm going to start on the right, and I'm going to come back to the left. So I got 1, 2, 3, 4, and 5 there. Any of them absolutes? The one on the left, that is an absolute right there. And that's going to be an absolute minimum, correct? Yes? Okay. Middle one. 1, 2, 3. Any of them absolutes? The 2 minimums are absolutes. Okay. Got one right there. Is it an absolute? Yes. Okay. All right. Question number 3. List any observations that we just noticed about the possible number of extrema and the degree of the function.
If the degree of the function is odd, there are no absolutes.
Okay, so if it's odd, there are no absolutes. I like that one. Odd degree. No absolutes. Because the function goes shooting off in opposite directions. I like that one. Another observation that we saw. Other observations that we saw. I'll give you one from the last class. The last class said that the maximum, oh, excuse me, not the maximum, no. They said the number of extrema is not more than the degree. Okay? So you can't have a cubic function with 8 terms. Okay? Alright? Anything else? Either that we talked about yesterday or that you observed on looking at page, whatever this page was, this page. Anything else?
Well, if it's only like x to the 4th, there's only one absolute value. Like, so if it's just
That absolute.
absolute minimum of x.
Yes, that's different than absolute value.
Yeah.
Yes. Okay, so absolute extrema.
Yeah.
Okay. All right. There can only be one-ish. Okay. Yeah. All right. Anybody else talked about it yesterday? I didn't nudge it out of you. It kind of goes along with this last point. Jacob, what do you got?
Seems like when the degree is odd, the number of extrema are even.
The possibilities. Okay. So let's go off of that one. How can I make an odd number become even? Subtract 1, right? So the maximum number of the extrema is equal to what? n minus 1, which n is the degree. So it's the degree minus 1. And then the other possibilities, they always differ by 2. Okay? So from whatever your degree is minus 1, then you subtract 2 and that's a possibility, then you subtract 2 and that's a possibility, all the way down until you get down to 1 or 0. Because you can't have negative terms. Okay? Alright, so my degree is 9. Right? What's the most number of terms that I can have? 8. 9 minus 1 is 8. What's another possibility of terms that a 9th degree? 6. What's another possibility? 4. What's another possibility? 2. What's another possibility? 0. With me? Okay. My degree is 18. What's the most extrema that I can have? 17. What's the next possible? Next. 13. Next. 11. 9. 7. 5. 3. And 1. Can I go any further? Nope, because that one's got to turn because it's even. So they have to be ending up going in the same direction. So it's got to turn at least once. Okay? So an nth degree odd polynomial. The maximum would be n minus 1, correct? And then that's going to go all the way down until we get to 0. And they will always differ by 2. And even will look the same, n minus 1, but it will always go down to 1. Again, differ by 2. What I'd like you to do now is, I would like you to turn to page 267. And on page 267, there's a chart. Okay? A power function is kind of like what we were talking about last week, Friday, where it's just a single term function. Okay? A power function is a single term function. Okay? A polynomial function has a bunch of stuff in it. Bunch of extra stuff. Extra terms, all that fun stuff. So if I go back here and I look at this one, here this is a polynomial function. This is a power function. Okay? Power's got one term. Polynomial has a bunch of extra stuff in it. Okay? What I'd like you and your shoulder partner to do now is, based off of that, I want you to answer the questions A through E on pages 267 and 268. Okay? Go. Similarities or differences between the power functions and the polynomial function. So part A here, what do we got for similarities or differences?
Okay, so we said that odd polynomial functions have more extrema,
Okay, odd ones have more extrema.
and then odd power functions have none.
Okay, so an odd power function does not have extrema. But the rest all do have extrema, right? Okay, of varying differences. Okay, anything else? Similarities, differences.
I don't know if it's right, but we said that the polynomials have many terms of more extrema, and the odd have one.
Okay, so the more terms, in the function, the more extrema you're going to have. Anything else?
So we said if, like some polynomials, if they're even, that they both go up, but they both.
So their end behavior is the same for both
Yeah.
power and, okay. What about for odds? Did you find the same thing?
No.
They're not?
They still
But they're the
yeah.
same, right? For both power, for an odd degree power function, they go in opposite directions. And an odd degree polynomial function, they also go in opposite directions, right? Okay? So, in summing up that one, we could say that the end behavior is the same. Not only in terms of power and polynomial, but from what we've been doing with it, right? Okay? Does that work for you? Okay, those work for me. So then let's go more into that end behavior. What conclusions can you make about the end behavior of all even degree ones? They go in the same direction, okay? So if both sides of the graph go in the same direction. What about odd? They go in different directions. Okay? What conclusions can you make about the domain and the range of even degree polynomial functions? Remember that in domain is our inputs, which is usually our x's. Range is our outputs, which is what the function is doing, or our y values that we get, right? Okay? So, domain, x's. You've heard me say there's three different types of numbers in this world, right? Positive, negative, and 0, right? Okay? Can I put a positive number into an even degreed function and get out an answer? Let's take x squared, for instance. Can I put a positive number in for x into x squared? Yeah, okay? And that's represented up here on these graphs by having stuff over here on the positive side of the y-axis. So right here is the positive numbers. Right here is the positive numbers. Right here is the positive numbers. Here is the positive numbers. I can put stuff in there, yes? Okay. Can I put negative numbers in there? Yeah. Here they are. And here they are. And here they are. And here they are. Can I put 0 in there? Yeah, it's right here. It's right here. It's right here. And it's right there. Right? So what's the domain then for an even function? Or an even degree function? All real numbers. So the domain is all real numbers. The range is a little trickier because the function has to end up going in the same direction. The range is restricted by the function. So let me go back up here. On this one, the range here would be y is greater than or equal to 0-ish. Okay? Here it would be y is less than or equal to 0-ish. Okay? Here, I would say something along the lines of y is greater than or equal to -4. Okay? Or wherever the scale is, you know what I mean? Here it would be whatever this maximum point is, y is less than or equal to it. Let's say 10 for that one. Okay? It's restricted by what the actual graph is of yours. Okay? An odd function. What's the domain of an odd function? All real numbers, right? It's on the negative side, it's on the positive side, it's at 0. Right? What's the range of an odd function? Remember, odd functions go in opposite directions, right? So the range is all real numbers again. Okay? So for an odd function, the domain is all real numbers, and the range is also all real numbers because one side goes shooting up, one side goes shooting down. So we'll hit every y value out there. Okay? What I'd like you and your shoulder partner to do now is I would like you to attempt to answer both question 7 and question 8 on page 268 and 269. All right, so looking at number 7. A value. Positive or negative?
Positive.
Why is it positive?
Because the right side of the graph is going
Because the right side of the graph is going
up.
up. Okay, all right, I like it. Odd or even? Odd. Why odd?
Different direction.
It's going in different directions on both sides, so this is an odd function. C. Can this function be a cubic function? Why can this not be a cubic function? It's got 4 turns, and the number of turns can't be more than the degree. Okay? So the minimal degree of this function would be, what's the smallest degree of this function? 5. Okay? But it could be 5, it could be 7, it could be 9, it could be any odd number bigger than 5. So this function cannot be a cubic function. Okay? Domain of this function. All real numbers. It's an odd function. Odd functions have domains that are all real numbers. Range of this function. All real numbers. It's an odd function. Odd functions don't range are all real numbers. Okay? Determine the number of relative extrema on this graph. I see one here. I see one here. here, and here. Those are our 4 that we identified when we were talking about the cubicness of it. Absolute extrema. None, right? Because it's an odd function. Okay, odd functions don't have absolute extrema. Okay, so there are none of them are absolute. Okay, intervals where the graph is increasing. Now here you have to go back and you have to look at your graph, and you're going to work your graph left to right. Okay, so as you take your finger or take your pencil or take your pen or take whatever it is you want to take, you're going to trace your graph from left to right. If, as you are going left to right, if your pencil, your pen, your finger is going up, it is increasing. If it's going down, it is decreasing. If it's not going up or down, it's staying constant. Okay, so we're looking for where this function is increasing. So I'm starting here at this graph, and here my pen is going up as I'm going to the right. So it's increasing. Then it's going down. It's not increasing. But then here now, it's increasing again. Then it's going down, not increasing. Then it's going back up, and it's increasing there. So I have 3 different spots where it is increasing. Okay? So my first interval here would be from negative infinity to, I'm going to go with negative 2.5 on that one. It's kind of halfway between negative 2 and negative 3. Yes? Okay. Then this one looks to be about from negative 1 to, I don't know, a third? Sure, we'll say a third. Okay. Then this one looks to be 1, 2, let's say 2 1/3, all the way to positive infinity. Right? Okay. So those then, when I put those in interval notation, that would be from negative infinity up to negative 2.5, we said. Then we're going to union that with, what did we say, negative 1 to about a third. And then we said from 2 1/3 all the way to positive infinity. Okay? With me? All right. Number 8. A value of this function, positive or negative? Negative. Why? Right side is going down. Okay, so it's negative. Odd or even? Why even? They're both going the same direction, so it's even. Could this be a 6th degree polynomial function? Yes, let's count extrema on this one. Oops, extrema was purple. Sorry about that. Right? Wasn't extrema purple? Yep, extrema was purple. On a stay consistent. 1, 2, 3, 4, and 5. So there's 5 extrema, which means I could be a 6th degree polynomial function. Domain of this 6th degree at least polynomial function. All real numbers. Range of this one. It's restricted, so what's it restricted to? Let me erase this part here. Looks to be a little bit more than 2, right? So what's a little bit more than 2? 2 1/3 again? Okay. And it's all below that, right? So this would be a restriction of, my range would be y is less than or equal to approximately 2 1/3. That's my restriction. It will never get bigger than that. So I cannot have an output of 15 from this particular function because it doesn't fit into my range. Okay? Determine the number of relative extrema on this graph. We said that there were 5 of them. 1, 2, 3, 4, 5. Okay? Are any of them absolutes? One of them is an absolute, and it just happened to be that one that we were just talking about. This one right here is an absolute maximum, because the function will never get any higher than that. Okay? Then now it's asking state the intervals where this graph is decreasing. So again, as I'm working left to right, now I'm looking for where my pen or pencil or finger is going down, decreasing. So that would be here, and then it would be here, and then it would be here. Okay? Not looking at y values there, I'm looking at x values because I'm working left to right. And so those x values would be from negative, let's say 2.5 to negative 1.5, along with, let's say, about 1/3 to, let's say, 2, and then along with 3 to infinity. That is where that function is decreasing. Okay? The green worksheet that I gave you at the beginning of class, 3-4 or 3.4, you will need a graphing calculator for that one, so it is due on Friday. Okay, that one will be due on Friday. Green due on Friday.